In this video, we'll be looking at the terminology and the different properties of circles, as well as looking at how we can find the circumference and area of circles. We'll see how we can give these as a decimal, but also in terms of pi and as an estimation. And we'll also be looking at calculating the arc lengths and areas of sectors of circles. In this first diagram, we can see the different terminology that's used when dealing with circles. First of all, the circumference is a word that's used to describe the perimeter of a circle, so includes the entire length of the circle, like this. The diameter is here, and it's a line that touches the circle twice and goes through the centre of the circle. The radius, which is here, is the distance from the centre of the circle to the circumference, and the radius is the same wherever it's taken from in the circle. The length of the radius is always half that of the diameter. An arc is created by the part of the circumference between 2 points. When you create an arc, you always create at least two of them, the smaller being the minor arc and the larger one being the major arc. When you create an arc using two ends of a diameter, the arc is referred to as semicircular. A chord is a line that goes through the circle twice, but doesn't go through the centre, otherwise it'd be a diameter, so that's this one here. The last line is called a tangent, which is here, which touches the circle just the once, and it's almost like the circle sits on the tangent, or the tangent sits on the circle. Now we're looking at two ways to describe the areas within a circle. The segment is the part of the circle that's made by cutting it with a chord, and as with an arc, you can have the minor segment, which is the smaller one, and the major segment, which is the larger one. A segment that's created using the diameter is a semicircle. Lastly, you have a sector, which is created by an arc and two radii. It's worth remembering that a triangle made of two radii will be an isosceles triangle, as all radiuses are equal. I say this as it comes up quite often in exam papers. Sectors look like pizza slices. Now, when dealing with circles, we're going to use pi, which is an irrational number, and it's stored to a good degree of accuracy by your calculators. Let's look at how to find that on the calculator. Quite simply, when trying to use pi on a calculator, we press the shift button here, release it, and then press the times 10 to the power of x button here at the bottom. It's worth checking on your calculator to make sure that's the same. This will give us the pi symbol, and if we press S to D, it will change it into a decimal, which is 3.141592649, and so on, as it never stops or recurs. We'll be using this number a great deal whilst calculating the area and circumference of circles. And let's find how this number is constructed. Pi is the number of times the diameter will go around the outside, or the circumference of a circle. So circumference divided by diameter would give you all the digits of pi if you wanted them, or just the first 10 decimal places on your calculator. This is plenty of accuracy for what we need and allows us to create our first formula, as circumference divided by diameter gives us pi. If we multiplied both sides by diameter, we'd get circumference equals pi times diameter. Let's take a look at how that's used on a circle. The diameter of this circle is 8 centimetres, so we can substitute that into our formula and get circumference equals pi times 8. So if circumference equals pi times 8, we'll do shift x10 times 8 will give us 8 pi. If we now press the SD button, we get 25.13. We can say that the circumference is 25.13 centimetres. However, we should also consider how we can give this in terms of pi, and in fact, we already have. When we stated the circumference was at 8 pi, we could have just stated that was the circumference. That would have been an acceptable answer. If they're asking for an answer to a certain amount of decimal places, we know we're going to need to press SD and then round it. This means you can use circumference on a non-calculator paper. Now, let's look at how you can calculate the diameter and the radius knowing the circumference. As we said before, the circumference equals pi times diameter. So if we substituted 45 in for the circumference, we can rearrange the equation by dividing both sides by pi, to get 45 divided by pi, which will equal the diameter. Once you've done that, if you press the SD button on the calculator, you'll find that this gives us 14.32, which equals the diameter. We know that the radius is half the diameter, so the radius would be 7.16 after we've divided the diameter by 2. Now let's look at how you can calculate the area of a circle. The area of a circle can be gained by using the following formula. Area equals pi times the radius squared. If we were calculating it for this circle, the radius is 12, so we'd substitute that in for the formula. The area would equal pi times 12 squared, which would give us 144 pi if we weren't using the calculator, or we could press SD to get 452.39 centimetres squared. As we're dealing with an area or the space inside a circle, we need to make sure we're using the units squared. Let's find out how to find the parts of a circle using these formulas and the angles that are given. In order to find the sector of this circle made from two radii of 10 centimetres each and an angle of 60 degrees, we use the formula for area and find the sector as a fraction of the whole circle. So the sector would equal area times angle over 360. So in this case, we'd substitute in the following values. The sector area is going to be pi times 10 squared, and then we'll times it by 60 over 360. This will give us 50 over 3 pi, or 52.36 centimetres squared. In order to calculate the arc of the sector, we can use the same fraction with the circumference this time of the circle. So the arc is going to be the circumference times the angle over 360. So in this case, the arc length will equal pi times 20 times 60 over 360, which will give us 10 over 3 pi, or 10.47 centimetres. Now, let's look at some exam-style questions using the area and the circumference of circles. Here, we have a circle with a radius of 20 centimetres. The shaded semicircle has a diameter of 16 centimetres. The question asks us to calculate how many times bigger the unshaded area is than the shaded area. Let's think about how we would calculate the larger circle. We calculate the area of the larger circle by doing pi times 20 squared. In order to find out the unshaded area, we would then need to subtract the area of the shaded semicircle, for which the formula would be pi times 8 squared divided by 2. Because 8 is the radius, and we're dividing it by 2 because it's a semicircle. Let's calculate these, and if we did, we'd get 400 pi minus 32 pi. Will give us 368 pi. If we divide this by the shaded area, we get 368 pi divided by 32 pi to give us 11.5. So we can say that the unshaded part is 11.5 times larger than the shaded part. So let's have a look at how to use estimation in the calculation of circles. I've included this as it can be used on non-calculator papers for questions that will include circles. It uses the word estimate, so we can round every number, including pi, to one significant figure. In this question, Sam has a circular patio with a radius of 5 metres. He's going to cover this with gravel. The bags of gravel that he buys contain enough to cover 27 metres squared. We need to work out an estimate for the number of bags he's going to need to cover the patio in gravel. As we're estimating, we can round pi from 3.14 and so on to just 3. This means we can say that the area will be 3 times 5 squared, 3 times 25, which would give us 75 metres squared. That's our estimation for the patio. As the bags are 27 metres squared, we can round that to one significant figure and say that they'll be 30 metres squared. This means we can calculate the number of bags by dividing the total area by the estimated coverage of the bags, 75 divided by 30. This will give us 2.5 bags. As we can't buy 0.5 of a bag, we're going to need to buy 3 whole bags to cover the driveway. In this video, we looked at the terminology that we use with circles, how to find the circumference of a circle, which is pi times diameter, and how to find the area, which is pi times the radius squared. We reviewed how to answer those questions in both a decimal and in terms of pi, and then we also looked at estimation. We looked at using the circumference and area of equations to help us calculate the arc lengths and the area of sectors of a circle. In the next video, we'll be looking at circle theorems. I'll see you then.